Hello everyone, welcome to the Intro to Polynomials lesson. Alright, we're going to start off by going before polynomials. Well, it's part of polynomials. It's a monomial. What is a monomial? Well, it is a single term expression Now, to call it a single term is kind of almost redundant or kind of like defining it with its own definition. So a single term expression, we could also say an expression of factors with no addition or subtraction. So something like 3x to the fifth. That's a monomial. Okay. Well, for a polynomial, we could define it as an expression of the form a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a sub 1 x to the 1 plus a sub 0. And you're like, what on earth is that? Well, all of those a's, a sub n through a sub 0, those are all just coefficients. And all those x's are just variables with exponents. So let's talk a little bit about this. The characteristics for this, we would say, is a0 through a sub n are real numbers. So that means fractions and decimals are allowed. Positive, negative, all allowed. Now, n through n minus 1. What are the conditions for this? N through n minus 1 must be whole numbers. So, while the coefficients can be fractions, decimals, and negatives, the exponents can't. We're just talking about specifically 0, 1, 2, 3, 4, whole numbers, no fractions, no decimals, no negatives. Okay, so let's look at some examples. So we could have an expression like 3x to the fifth minus 4x squared plus 2x minus 19. Great. That's a polynomial. Lots of coefficients, lots of variables with different exponents, and you might think this last term doesn't have a variable. Well, it's kind of like x to the 0 power. So even in our definition, we could call this like x to the 0 here if you wanted to include that there, because x to the 0 is 1. All right, let's think of some other ones. Well, that one had, we'll talk about that in a bit, but 4 terms, so we could also have like negative 4x to the 15th. Just by itself, we could have 2x squared minus 4. We can also have things with other variables in there, like 2xy minus 9x. So many different ways we could show polynomials, but we can't probably list all of them. So let's look at some non-examples to see what would be wrong. Okay, 3x to the negative 5. Nope, can't do that. Other things we can't do would be like 2x squared plus 1 over x. That 1 over x is a problem. We can't have x on the bottom because that's really like a negative exponent. We also can't have 4x to the 3/2 plus 2. Can't have fractional exponents. So all of those would be problems. All right, well that was exciting. So let's play a really exciting game. I like to call it, is it a polynomial? You have to say it like that. If you don't say it like that, I don't know, the game doesn't work. Anyways, so let's talk about, is it a polynomial or not? Okay, so number one, we're looking for x's or variables in the denominator. We're looking for negative exponents. We're looking for fractional exponents. Yes, this works. And I guess I could list that it does not have any of those things, maybe for the ones that if not, really just explain why not. So that's probably what we really need to say more. So when we look at the second one here, 5x to the negative second, No, and that's because there's a negative exponent. Bad news, can't have it. Number 3, looking at each of those pieces, yeah, that works. We have all whole number exponents. Great. 11, that seems too simple. That can't be, is it? Yeah, it actually is. You're like, but what about the variables? Well, we could call that x to the 0 if we really wanted to. Square root of 3x. Well, do you remember that a radical here, this is a second root, a square root, this would be the same thing as 3x to the 1/2. Ooh, so that is not going to work for us. The x now has a fractional exponent. But what about number 6? We have the square root of 3 times x. Well, square root of 3 is a real number, so that's okay. And oh, I'm sorry, I should have said no here. And this is a fractional exponent. Fractional exponent. This one is yes, because we're allowed to have a real number coefficient, and we have a variable with a regular whole number power. All right, ooh, 7. I see all these fractions, but actually that's fine. What we can't have is we can't have fractional exponents, so we can't have x on the bottom. We could rewrite this as 1/4 x plus 1/3 x squared. Now we have clearly real number coefficients and variables with whole number exponents. Okay, there's some more down here for you to try and consider, but we're not going to go through them all right now. All right, so let's look on to classifying a polynomial. So part of classifying a polynomial, we'll be talking about the degree of a polynomial. The degree of a polynomial is the highest exponent of the polynomial. Okay, so if we just have a degree 0, meaning like x to the 0, so meaning that there's no variable actually likely to be seen, we would say that is just a constant. If it's a degree 1, that is linear. Degree 2 is quadratic. Degree 3 is cubic. Degree 4 is quartic. Degree 5 is quintic. And we probably could find some other names for some bigger ones, but if it's anything bigger than 5, we're just going to say degree and that number. So degree 6, degree 7, anything like that. Okay, what about the number of terms? If there is one term, we talked about that at the beginning, that is a monomial. If there are 2 terms, it is a binomial. 3 terms makes it a trinomial. Anything more than that, we're just going to call it a polynomial. Hey, that's the name of the chapter here. Okay. There is such thing as standard form of a polynomial. So for a polynomial to be in standard form, it is written with the terms in order of decreasing degree. So let's go ahead. We're going to classify some, and we're going to write them in standard form if they're not already. All right, so we look at number 13. We see the highest exponent is 5, and we see there are how many terms? Well, terms are separated by addition and subtraction. 1 term, 2 terms. So this is a quintic binomial. I tend, and I think most mathematicians would tend to put the degree first and then the number of terms second. Okay, now the first term has a degree 5 and the second term has a degree 0. So these are in decreasing order. So this is already in standard form as it is. All right, second one. Looking through our exponents. Highest exponent actually didn't come first. It's a degree 4 over there. Well, 4, we can call that a quartic. And since there are 3 terms, we can call that a quartic trinomial. Now, because the highest degree term is currently listed second, we're going to rewrite this with that term first. So 2x to the fourth comes first, and then plus 4x to the third, that's our next highest degree, and then minus 1 at the end. Terrific. All right. This next term, highest degree is 2, so that's a quadratic. Only one term, so it's a monomial. For some reason, number 16 often throws people off. So if we just have a number like 12, all right, well, it's really like got an x to the 0 hanging out there, because x to the 0 is 1. So it's like degree 0, and for a degree 0, we just say that is a constant. So it's a constant, and there's one term, so it's a constant monomial. Okay, lots more examples that you can definitely try on your own. Let's look for something that maybe is a little fun here. Let's go ahead and let's try 44 here. Okay, so I'm looking. I'm looking at all the variables, and I'm looking at their exponents, and I see this one has a 5 there. So that makes it a quintic. How many terms? There's 1, 2, 3, 4. Okay, so there's 4 terms. That's over our 3, so we're just going to call it a polynomial. Okay, let's write them in order of decreasing degree. 5a to the 5th is first. Our next one would be the plus 10a to the 4th, then minus 10a squared, and plus 3a. And that's in standard form. Okay, thanks so much for watching this Intro to Polynomials lesson. We found the degree, we wrote things in standard form, we talked about how many terms there were, we decided if things were or were not a polynomial. Thanks.